So, very good morning to all of you, and thank you so much for session chairman and IPTA committee for giving me this opportunity to present my paper here. So basically, today I'm going to present my research work on enzymatic bleaching. We all very well aware of the enzymatic bleaching. So here I will talk about the three main objectives. First objective is to find out the exact trend of hexanuronic acid by using gelineage enzymes. Second objective is how much brightness gain we can get after the enzymatic treatment in bleaching process. And the third objective is how much we are able to reduce the bleach chemical consumptions by removing the hexanuric acid components from the fiber. So I will be talking about enzymes and what factors affecting the enzyme actions. I will also talk about the conventional and enzymatic bleaching. And I also go through for what is the hexanuronic acid and what is the mechanism of hexanuronic acid formation during the pulping process. For the results, I will talk about the trend of hexanuric acid removal during the ECF bleaching, and at the last, I'll summarize my research work findings. So, what are the enzymes? We all know that enzymes are protein, and they catalyze biological reactions. And because every process needs activation energy, that is called the threshold energy, to convert into the product. So what enzymes do? Enzymes lower the activation energy to increase the rate of reaction. And we can also say that enzymes are very specific in nature, so they work on the lock and key model. What is the lock and key model? A model for enzymes substrate induction suggesting that the enzymes and substrate possesses specific complementary geometry shapes that fits exactly into one another. What is the meaning of that? Because we could talk about the amylase enzymes. Amylase cannot work on the cellulose fiber, and cellulase cannot work on the hemicellulose. Likewise, gelinease cannot work on the cellulose. So each enzyme has its own substrate to work. Sometimes we also see that enzyme gets denatured. What is the denaturation process? Denaturation process is that where structure of the protein or their functional groups undergo for the conformational changes and resulted into the inactivity of that enzyme. So if enzyme is denatured, then what is the meaning of that? Enzyme cannot bound to its substrate and become and loses their functioning in the process. So enzyme will not work at all then. Sometimes enzyme also need some cofactors, like they also need the support to get activated in the system. So they need the cofactors like these are the non-protein molecules, and sometimes it may be the metal ions or vitamins. I'll give you some example like lackage. Lackage is a very good bleach boosting enzymes, but it always need a mediator. Mediator is like HBT, hydroxybenzene triazolure, but this mediator is very costly. So it make the lackage mediator system very costly, so it is not viable at industrial processing. So we chosen the gelineage enzymes for our study because this provides the alternative and cost-effective process to remove the hexanuronic acid, to remove the to reduce the bleach chemical consumptions as well, and it also reduces the pollution load from the bleach effluent by reducing the BOD and COD and all. So there are some factors also which may affect the activity of enzymes like pH and temperature, because each and every enzyme has their own optimum pH range. Below and beyond that pH range, enzyme will loses their activity and stability as well. So pH and temperature are the main crucial parameters which affect the enzyme actions. Likewise, substrate and enzyme concentrations also major parameters which can affect the enzyme actions, and enzyme will not work at 100% activity. When we use the enzymes, we always need to optimize the retention time for each and every applications. Like if you talk about the bleaching process, we need at least 1 hour to make our enzymes 100% active. If we talk about the refining enzymes, then this can be happen only 20-25 minutes are more than enough to work on that. So likewise, mixing is also important. Enzyme and substrate mixing should be homogeneous to work to get the 100% results from the enzymes. So what are the bleaching actually? We all know that conventional bleaching requires lots of chemicals to remove the color part, that is a lignin component from the fiber. There are some advantages also, but the conventional bleaching leads to major disadvantages, like they generate lots of hazardous chemicals which are not good for the human as well as aquatic lives. And conventional bleaching chemicals also increase the AOX generation, so they increases the cost of secondary treatment. So this is not viable for the longer term. So we have to find out the alternative solutions. So here the alternative solutions is enzyme, because enzyme always provide the green manufacturing practices in every industrial part and industrial application. Enzyme is also responsible to increase the brightness and whiteness of the pulp, and it can reduce the consumptions of chemicals like chlorine dioxide and sodium hydroxide as well. Use of enzymes, Jalen enzymes always reduce the AOX reduction, which results in the higher BOD-COD ratio. What is the meaning of higher BOD-COD ratio? When BOD-COD ratio will be higher, then the effluent become more degradable at secondary treatment. So it lowers the treatment cost in ETP. So what are the disadvantages of the enzymes? Enzymes, I must say there is no disadvantage of enzymes. They are 100% safe and biodegradable, because in our paper industry, there are so many up and downs in pH and temperatures. So enzyme easily get deactivated after using in the process. So there is no side effect. We can easily use enzymes in each and every process in paper industry. Another crucial part is dosing point. We have to optimize, we have to see where we add to our enzymes so that we can get maximum benefit of that. For the enzymatic bleaching, the best part is after brown stock washer, where we get pH is around 7 to 8.5 and temperature is around 55 to 70 degrees centigrade. We also get the enough time to go for the first bleaching stage. So this is the best stage where we can add enzymes, and this is called the pre-bleaching process. We followed in our study ECO bleaching sequence, that is D0, EP, D1, D2, where D0, D1, D2 are the dioxide stage and EP is the extraction stage with alkaline peroxide. So now come to the main part. What are the hexanuronic acid and what they enhance in the enzymatic bleaching? So hexanuric acid is a 13 carbon chain bicyclic compounds and it is produced during the kraft pulping process. We have to understand what happens during the kraft pulping process, so hexanuric acid forms. So I will see in the next slide. What hexanuric acid do? They actually contribute approximate 33 to 67% copper number in the hardwood kraft pulps, and they contribute around 5 to 12% copper number in softwood kraft pulps. So because hexanuronic acid is responsible to consume all the KMNO4, that is potassium permanganate, during the estimation of the copper number. Hexanuric acid also reduce the penetration of the bleach chemical consumptions to remove the lignin from the fiber. So this is the mechanism of the hexanuric acid formation. I'll explain what happens. We have to understand the pulping process to understand the hexanuric acid formation. We use the white liquor, which is having a highly alkaline condition, like we made white liquor by using sodium hydroxide, sodium sulfide, and sodium carbonate. So cooking process is divided into two zones, like one zone is impregnation zone and one zone is cooking zone. What happens in the impregnation zone? Impregnation zone is highly alkaline condition with a low temperature. During that highly alkaline conditions, almost 90% of the methyl glycolic acid is linked with the xylene released and removed from the system. But as well, 85 to 90% of the residual methyl glycolic acids are converted into the hexanuronic acid during the impregnation zone. And at the time of the 130 degrees centigrade, where we retain the process, pulping process for 1 hour, at this time, all the native xylene becomes free in the system, and all lignin will be free, and hexanuric acid also will be free that temperature. What happened at the end of the cooking process? That is at the temperature of 160 degrees centigrade for the hardwood, where alkali concentration is less. So the native gelatin, which is free in the system, again reprecipitated on the cellulose fiber. So what happened that time? That time, free hexanuronic acid tried to make a bond between the gelatin and itself. So during the formation of the bond, the free lignin entrapped between these complex. And this entrapped lignin is very difficult to remove by using the bleach chemicals. So when we give the bleach chemicals to reduce the lignin components, this hexanuronic acid hinders the penetration of that bleach chemicals into the lignin. So what is the solution? Solution is only gyalinase treatment. When we give the gyalinase hydrolyzes the gyaline and they break the bond between hexanuronic acid and gyaline, so the entrapped lignin will be free. And that free lignin will consume lesser bleach chemicals to remove it from the system. So now come to the result part. I used in my study 4 different enzymes with different activities and coded as NGA, B, C, D. And we taken the standard pulp like having a copper number of 18.5, 31.7 brightness was there, 12.8 viscosity was there, and hexanuric acid estimation was there at 21.3 that time. These are the application conditions which we have followed throughout the bleaching process, including the enzymatic stage. So after the enzymatic stage, we were able to reduce approximately 17% copper number with the use of NGC, and we were able to reduce 16% of hexanuronic acid with the NGC, with gaining 2.6 units in the brightness. Some viscosity improvement is there because probably due to the gelatin-induced dissolution of the low molecular weight of gelatin components. So a little bit brightness improvement was there. When we reduced hexanuronic acid with the gyalinase treatment, gyalinase also facilitated the improvement in the brightness and reduction in the brightness reversion. That is called PC number. So we were able to reduce 35% PC number at the same kappa factor, and we were able to reduce 27% PC number when we reduced the kappa number by 15%. Some shrinkage improvement was there. It clearly shows that enzyme removed the organic load from the system. That is, it reduces the hexanuronic acid. So sometimes enzyme also destroy the gelatin. So it may be the cause of increase in the shrinkage and some pulp yield loss. We also got the 24% BOD removal reduction at the same kappa factor and approx 27% COD reduction with the use of enzymes in that is NGC. This is a table of final brightness improvement. Here we can see that 1.5 unit of brightness was there at the stage of the final stage, that is D2 stage, at the same kappa factor, and almost same or 0.6 unit again was there at reduced kappa factor. This is a stage-wide reduction of hexanuric acid where we estimated hexanuronic acid reduction at each and every stage. And we got the shocking results that hexanuronic acid reduction was maximum at the extraction stage itself. Approximates 41% reduction was there at same kappa factor. And after D2 stage, it reduced almost to 17%. Here we can see in the graphical representation that 41% copper number hexanuric acid is reduced itself in the EP stage, that is extraction stage, and 17.5 hexanuric acid reduced at D2 stage. So overall hexanuric acid reduction was then 91% from unbleached pulp to bleached pulp. That is a huge amount in the reduction. So we were able to reduce the bleaching chemical also. We got these results by saving 15% of chlorine dioxide and approximately 20% of the sodium hydroxide by keeping the same parameters of optical properties and all. So this is a summary of my presentation. That is, after the excess stage, we reduced 16% hexanuric acid, and we got the 2.6% unit in brightness gain, and 17% reduction in the copper number. After the last dioxide stage, we were able to reduce the 17.5 hexanuric acid, 1.5 unit brightness gain was there, and we reduced almost 35% PC number. We were able to reduce BOD and COD by 24 and 27% respectively. Enzymatic treatment also leads to bleach chemical reduction by 15% and 20% for chlorine dioxide and NOH respectively. So here we reduce the bleaching chemical almost to 15% and 20%. That is indirectly we are saving the energy also, which energy required to produce these bleach chemicals. So we are saving the greenhouse gas emissions also, which is equivalent to that energy which is required to produce that bleach chemicals. So I must say that want to say to paper industrialists that we don't hesitate to use the enzyme treatment in your process, because enzyme use is very easy. They can give the cost-effective process also. They are safe for the human as well as aquatic lives. So think for it and go for it. Thank you so much.